Okay. Kristel, please. And Kristel comes from State Shared Service Center, Estonian authority, who is pretty much organizing climate proofing procedures and knows why it's done and how it works in Estonia. And then we will move to the practical examples. And then Mart, is your turn. Then Kristel, please, floor is yours.
Thank you. And just to check if you can view my presentation in the correct mode and if you can hear me clearly.
At least I can hear you well, and I can see also presentation.
Okay. So I will start off about introducing the State Shared Service Center of Estonia, which is a very long name for a government agency which works under the Ministry of the Finance. And I'm part of a team of experts who support the development of grants. And our agency deals with all EU-funded grants and is also an implementing body for about 70% of the total amount of EU funds. So my role as an environmental expert is to make sure that all the grants which are given are in accordance with all the financial rules and regulations. And one of the main topics in the new period, as we call it, which started from 2021 up to 2027, is the climate proofing of infrastructure investment. This is further or in detail described in the Common Provisions Regulation, which we refer to as CPR. And it states that climate proofing of investments should be an integral part of programming and implementation of the funds. So this is a basic principle that needs to be followed throughout the funding period. And on the other hand, it must be kept in mind that the energy efficiency first principle also applies when selecting possible operations. And the regulation also defines what is meant by climate proofing. It is actually a wider process, not just an assessment, but a wider process to prevent built infrastructure from being vulnerable to potential long-term climate impacts. As I said, energy efficiency first principle should be respected, and also the project or the infrastructure investment must be in line with the climate neutrality objectives. And this responsibility is further put on the shoulders of the managing authority, which I'm representing, and managing authority shall ensure that all these investments regarding infrastructure, when selecting them, they have to be climate proofed. And there is one condition, which is the lifespan of the investment. It should be at least 5 years, so more than 5 years. The first period or the first time when climate proofing was implemented was actually in the previous period. And then it was a condition for major projects. In that case, the beneficiary or the applicant had to provide additional information on the major project. And this included an analysis of the environmental impact, taking into account climate change adaptation and mitigation needs. This was also a part of the cost-benefit analysis, and climate change aspects were also part of the feasibility, option, and economic analysis, as well as part of the risk assessment So this was the first experience when implementing this sort of climate proofing concept. But in the new period, which we are implementing in Estonia at this very moment, we have new legal rules and also new methodology, which has been updated by the European Commission. So actually in autumn 2021, this document with a link on my slide, which is called the Technical Guidance on the Climate Proofing of Infrastructure in the period 2021 plus, gives a general overview of climate proofing, why it's necessary, what does it mean, the methodological choices, as well as additional information about combining with environmental impact assessment or project development in general. As I'm working with environmental funds and the managing authority is responsible for cohesion policy or recovery funds, there are also other types of funds which Estonia is using or not using, for example, InvestEU or Connecting Europe facility, which also have the same requirements. Estonia is also in the beginning of implementing Just Transition Fund, and Mart will tell further about his experience in that part. But it must be also kept in mind that all the big investments which will be made in Estonia as part of the Just Transition Fund will have to be climate proofed. So as a short introduction to the technical guidelines, first it defines what is an infrastructure, and this is one of the main questions which is also asked either by consultants or other authorities. So actually there is no legal certain definition, but the technical guideline describes what can be the different types of infrastructure projects. And it is a wide variety, starting, of course, from buildings, but it does include also nature-based infrastructure, different network infrastructures, also waste management systems, and other physical assets. In some regulations, for example, in InvestEU regulation, there is also a wide complementary list of all these infrastructures or projects which need climate proofing. This guidance also includes a quite thorough overview of how to streamline climate proofing with project cycle management, environmental impact assessment, and strategic environmental assessment processes. It also gives recommendations and supports the overall process. And as I said, that there is a wider concept behind, not just an assessment which has to be carried out for a project, but it means that during the project development phase, at the earliest phase possible, already climate proofing needs to be taken into account. For example, if there is no certainty about the location, then choosing the right location based on evidence or information which is useful for climate adaptation is necessary. So this process is actually much more broader, and one part of it, which we call the climate proofing assessment, this is necessary for funding decisions. This technical guideline also describes, of course, in further detail, how to carry out this sort of assessment, and it has two pillars. So one of them is climate change mitigation, which we call the carbon footprint. And the other is the adaptation to climate change or climate risk assessment. And the outcome of this assessment is, of course, a report which should be documented and verified. So to make a basis for investment decisions. So also shortly about these two pillars that I mentioned. They are parallel processes. First is climate neutrality or the mitigation of climate change, and the second pillar is climate resilience. And both pillars have two phases. So there is one phase which is called the screening phase, and the other which is called a detailed analysis. And why there are two phases is because projects have different impacts. And this offers a sort of threshold so that projects which do not have a very big impact, they do not need a detailed analysis. And that's why this technical guideline divides one pillar or a topic into two phases. And this is also because it's an administrative burden, of course. From the viewpoint of managing authority, this requires applicants to carry out additional analysis, and this is taking time and resources. So that's why it should be proportionate to the benefit of the project. So going a bit more into detail, then in the first phase, which is called the screening phase of the mitigation of climate change, this guideline presents a screening list. So as a first step, it should be made clear whether carbon footprint assessment is necessary in the first place. When it is, then the second phase begins, which means that an absolute and relative emissions need to be calculated and compared with the threshold, which is 20,000 tons of greenhouse gas emissions. And above that threshold, additional assessment needs to carry out, which takes into account the shadow cost of the carbon, also energy efficiency first principle, and the credible pathways to climate goals or reduction targets need to be taken into account as well. So for adaptation to climate change, a similar approach is used, but in the screening phase, it requires that a basic level of risk assessment needs to be carried out to identify at least medium or high risks, which we call the significant risks. And if these are identified, then they need to be addressed by relevant adaptation measures. And these adaptation measures are important to be implemented as well in the future by the project team. And also recommendations about monitoring or any follow-up activities should be presented as well, and compared also with the national or regional strategies on climate change. So now coming to the part how we have implemented climate proofing in Estonia. First, regarding my job as an expert for managing authority, we have we draw the guideline for the implementing bodies, which work with the conditions to provide grants. So this basically means that in the first phase, we will put in place for which activities or operations climate proofing is necessary. and what are the methodologies that has to be used. In the second phase, when it's already decided as one of the conditions for applying for grants or support, then we have developed an additional guideline for the applicants, which is actually more usable for environmental experts or consultants. And this will help to navigate in the Commission technical guidance, because it's quite detailed, but on the other hand, it's missing this information which is necessary for one particular region or for the country in question. So we have updated that guideline with the necessary information that we have on the level of the country. What's also in the pipeline is guidelines which are being developed by the Ministry of the Environment to help to integrate environmental impact assessment and climate proofing. So this guideline will be ready in the nearest future. There is also a dedicated web page which includes the information about the guidelines and about climate proofing in general. And unfortunately, it's in Estonian at the moment, but I think it's usable also to help to find information quickly. There is also a toolkit which we use or recommend to use when carrying out climate proofing assessments. First, as was mentioned earlier, all the relevant strategies for adaptation to climate change or studies on climate change mitigation and adaptation are very handy, because they provide the context and also the information which is necessary to carry out this sort of assessments. On a general point, this information needs to be updated regularly. So of course, there is some information which is missing, and that has to be addressed in the assessment. What is also providing some extra help is the taxonomy regulation, and its delegated act, which provides technical screening criteria for many different economic activities. And they also give an idea what are these adaptation measures, or what are the thresholds for sustainable economic activities. We have also developed greenhouse gas or carbon footprint calculation tool for Estonia, and it includes national emission factors. So this is available to all the organizations who are interested in calculating their footprint. And this is also one of the useful tools that can be used in the climate proofing assessment as well. So this is almost the end of my presentation, but based on our implementation experience so far, there are some recommendations that I've put on the slide. So first recommendation is that since it carries an additional administrative burden for different bodies or beneficiaries, the proportionate principle or the proportionality should be kept in mind to avoid unnecessary time and cost. This means that the report should be as brief as possible, focusing on the main elements of climate proofing. So also in the guidelines, there is one annex, Annex B, if I'm not mistaken, which describes how or what to document, and it also suggests that the full report should be around 10 to 20 pages, but this is just a rough estimate. For screening phase, only maybe a couple of pages are enough. Also, it's very important to define what is infrastructure and to determine the project boundaries, because these are the basis for calculating carbon footprint. Also, the documentation should provide a description of the methodology and data which was used, and of course the limitations. And the assumptions that were made should be as conservative as possible. To sum it up, conclusions must be drawn whether the investment is in line with climate goals, whether the adaptation measures have been clearly stated so that they are ready to be implemented, and also at a later stage monitored that actually the investment has been carried out as climate proof. And when feasible, then climate proofing assessment and environmental impact assessment can be combined as one process. There are some projects which have a very long timeline, and in some cases the environmental impact assessment has been carried out previously, so climate proofing assessment can support in its methodology the missing information that is necessary for making financial decisions. So to sum it up, in conclusion, climate proofing is a process that integrates climate change mitigation and adaptation measures into the development of infrastructure projects. So as I mentioned, it's a wider process to take the most advantage the advantage of the whole assessment, and part of it, as I said, is this technical assessment that is necessary to make informed decisions on projects and to give funding. And it also is necessary that all the risks need to be taken into account and should be minimized or avoided during the implementation phase of the project. So I will finish here. Thank you. And as I understand, I will answer the questions or comments after Mart's presentation.
Yeah, thank you very much, Kristel, for an excellent overview. Yes, there are no questions in the questions and answers sector yet, but I'm sure there will be, because but maybe with help of practical example given by Mart, there will be more questions. So please prepare them and feel free to write them down also in the questions and answers section. But let's now go to the practical part, and let's describe one of the cases of climate proofing. And I give floor to my colleague at DGE, Mart, please.
Yes, thank you, Heikki. Thank you, Kristel, for the introduction. Just want to make sure everybody can see what I'm seeing right now, which is the first slide of my presentation.
Yes.
Yeah.
Fine.
All right. Yeah. So let's. So now that we've covered some of the legislation, let's try to go into a specific example. I won't focus too much on the legislation again, but a couple of things that Kristel said resonated with me when it comes to defining the scope of climate proofing, and that is, first of all, how do you exactly define infrastructure is a relatively open question, but in this case, it includes, at least for us, manufacturing facilities. It's consistent with do no significant harm, energy efficiency, and the Paris Agreement. So let's move on to what the project was. So early last year, we had a client come to us, NPM Silmet. They operate under various business names, but this was one of them. They are building a rare earth metals manufacturing facility, in Eastern Estonia. The project will be about 100 million euros, give or take, to put into action. Production will begin in 2025. In order to supplement their funds, they needed about 18 million from the Just Transition Fund. And as we've just sort of covered, these kinds of EU funds, they require climate proofing for any major projects, including this kind of manufacturing. The last thing I'll note about this project in general, which was interesting to me, it will be the first one of its kind in the Western Hemisphere. So far, 100% of rare earth metal magnets are produced in China or Japan. So shorter supply chains, various other benefits. All of the magnets will be used in renewable energy projects, wind turbines, electric vehicles. Okay, so a reminder of the climate proofing process. We have the two pillars: climate neutrality, climate resilience. I like to think of these in terms of what is called the double materiality principle. I think of climate neutrality as risk arising from the project to the climate, and climate resilience as the risk arising from the changing climate conditions to the project itself. They both are divided into two phases. Phase one, you identify, is there a significant risk? If there is, you do a detailed analysis. That's basically it. For the magnet manufacturer, we did both of the climate neutrality phases. And for climate resilience, we just did phase one. The risks were relatively low, unless there may be specific cases in Estonia where you might need to go to phase two. We haven't encountered that yet. There are increasing instances of storms and flooding, for example, in Estonia over time that are projected. But generally speaking, climate risks are relatively low, and I haven't encountered a detailed analysis requirement for climate resilience. So this presentation will be almost entirely about climate neutrality. A quick reminder of what the climate neutrality process is. On the left side is sort of how I boiled it down into sort of a three-step procedure. The first one is simply looking at a screening list of activities to see if your activity is something that automatically goes to phase two. The screening list includes a term called manufacturing facilities. If I'm remembering correctly, it's very general, and definitely if you're doing any kind of heavy manufacturing, you're automatically going to go to step two. Step two consists of two phases. The first one is simply doing a carbon footprint assessment. How much greenhouse gases do you generate in a year? If that amount is above 20,000 tons of CO2 equivalents, you continue to step two of phase two. And you do a couple of other things, which I will go into. So before you kind of dive into all of this, and Kristel made reference to a couple of these terms as well, you need to define the project boundary, and you need to define the baseline scenario. The project boundary sounds like it maybe should be simple. Oftentimes we have clients who come to us and they say, okay, this is what I put in my funding application. I'd like to install this equipment in my new warehouse, or I'd like to build a new manufacturer. And so please do climate proofing just on what is in this application. However, according to the methodology, you kind of have to include, you have to think of it in a life cycle sense. So you have to include aspects of the business or the business model that are relevant. So if you install a new equipment, you can't just analyze the new equipment. You got to analyze the entire business. There might be a sister facility involved that provides power. All of these things may or may not be included. But again, this is a tricky issue. And the second thing you do is you define what the baseline is. So you need to to measure or compare the facility to something else. It's usually the likely alternative to the plan or project if it didn't happen. Okay, so in our case, in order to sort of determine the baseline, well, like I said, the only other facilities of its kind are located in China or Japan. So ideally, you would look at the emissions of a typical Chinese facility and compare it to what they're planning to do in Estonia. In our case, this was not, we couldn't do it quantitatively. We couldn't do it very well because we didn't have data on the Chinese or Japanese facilities. So we did a qualitative analysis as best we could. But again, this is sort of adapting the methodology to the data that we actually were able to reasonably ascertain. So you've got the project boundary set, you've got the baseline scenario set. First part of phase 2, do a carbon footprint assessment to see what they generate in a typical operating year. Now, as you may know, the most common methodology is the greenhouse gas protocol, which is divided into 3 scopes. Most company emissions are actually in scope 3, which are the indirect emissions. But again, scope 1 is what they generate on site or in the facility. It's the fuels they burn in their cars, or if you're a power plant, you will obviously have a very large scope 1. Scope 2 is the electricity and heat and steam that you purchase into the facility. And scope 3 is, well, some would say everything. There's a lot of categories, and they're not all mandatory. So let me give you an overview of some of these categories. They could include business travel, anything upstream, what's happening with your suppliers, what's happening downstream with regards to the use of your products. These can be calculated. From at least our interpretation, we need to choose the categories that are most relevant for the assessment, that have the greatest impact, and optimize just those, so that we can kind of downsize the project to the scope to what is relevant for, let's say, one manufacturing facility, as opposed to a much larger project. So we chose the first category, purchase goods and services, and actually we made it even more specific than that. We chose raw materials, since rare earth metals kind of just screams high CO2 emissions, at least to me. And I think we turned out to be correct on that measure. So here are, we crunched some numbers. Here are the results. Basically speaking, given the data we have, in a typical operating year, they would produce in this facility about 46,000 tons of CO2 per year. Most of these are scope 2 and 3. So they're relatively evenly divided, with scope 3 being the largest. For scope 2, there's the largest impactor is electricity that they purchase from AC Energia, or they will. And then scope 3, again, is rare earth metals. And in particular, this one rare earth metal, or an alloy, called neodymium praseodymium, if I'm saying that correctly. So these 2 components, electricity and this one particular rare earth metal, pretty interesting to work with when you're actually trying to get some mitigation going for these kinds of emissions. So we did the annual footprint, the thresholds. So you don't have to do detailed analysis if you're under 20,000 tons of CO2. We're more than double that. So we continue to part 2 of phase 2, the detailed analysis. Again, this basically consists of 2 components. One is verifying credible pathways to 2030 and 2050 emission reduction targets, which is a lot of fancy language, but I'll open that up a little bit in the next slide. And the second component is carrying out a cost-benefit analysis to basically determine if the greenhouse gases emitted over the life cycle of the project are worth it to society. Again, detailed analysis, 2 parts. This is kind of part 1 of detailed analysis. It can use several methodologies. It can get really tricky. You can use science-backed targets, which is a very deep and expensive and resource sort of necessary methodology. However, at least from our interpretation of the guidance documents, you can also take a little bit more of a simple approach. So we're just trying to So what we basically did is we looked at different EU, national and local level legislation and development plans for climate action, particularly with respect to what they require for 2030 and 2050 emission reduction targets. Of course, you want to once you've done that, you want to screen out any activities that are not consistent with the plans. You're definitely not going to be building any fossil fuel, plants, most likely at least under EU funds. So you'll screen those kinds of activities out. And then lastly, for all the other activities that actually do emit greenhouse gases, you want to develop mitigation measures that are sort of reasonably doable in this scope. So again, we developed some mitigation measures for everything that wasn't screened out. And I would look at these as sort of the first green, they're the first components that give the project a green light once it's gotten to the detailed phase, because theoretically speaking, yes, your application could be pushed back if it doesn't meet these criteria. To my eye, the 2 primary measures that gave the project a green light under these different circumstances is, the first of all is their scope 2, so their electricity use. This is actually largely out of their hands, and all we had to do was identify that their energy provider, AC Energia, is following the relevant climate plans, and they actually have made a commitment to produce carbon neutral electricity by 2035. I'll just skip ahead and show you the next slide. So this is the kind of data that we included in at least the quantitative part, and also just our basic assumptions. Secondly, for scope 3, we wanted to make sure that we reduce their scope 3 emissions as much as possible. This can be done, and they've made a commitment to include the capacity to use up to 10% recycled magnets. So basically, they need to install equipment that can melt down old magnets, and then use that in their process. Secondly, they made a commitment to do research into replacing carbon-intensive rare earth metals. We saw that particular one for less intensive ones. So these are the 2 major green lights that, if you do these, you've reduced your emissions quite a bit. Additional measures was smaller, but still important. Still large importance were for us the requirement to include waste heat recovery technology. So instead of purchasing energy into the building, they could use the heat from their own technological processes and lower their energy needs. Second was installing solar panels, focusing on energy efficiency, including best available technology, energy audits, and even just improving their landscaping and quality of the greenery in order to suck CO2 out of the atmosphere. A note about these mitigation measures, and Kristel made mention of auditing before. They're at this point, maybe they're phrased as recommendations, but they actually become requirements for the project. They need to be implemented into the project design. And don't have knowledge of the auditing process at the EU or maybe the national level if it's been done yet. But they can audit this at a later date to make sure that you've taken these things into consideration. So the last topic I will talk about is sort of part 2 of phase 2. Again, I would look at this as, and I think of the cost benefit analysis as sort of the final test. in order to get a green light and make sure your project is climate proofed. It's a cost benefit analysis. The test is the benefits of the project must outweigh the cost. So there are several things that can go into a cost benefit analysis. There could be hundreds of components in a true cost benefit analysis. For the purposes of this project, and due to the scale of the project, we boiled these down as much as possible to make it doable within this context. So what the methodology really is getting at is what are these emissions cost to society? So that's on the cost side. On the benefits, there are a couple of different things that you could use. One is simply the market value revenues of the company. That's kind of obvious. Another thing is how their products will be used downstream. Wind turbines, electric cars, obviously very good things. The problem with including downstream use in our CBA, though, is that it's very tricky to analyze, and that could also get very resource intensive. However, what we did was, if you can show that the company is profitable, even if you include the cost of greenhouse gas emissions, then the benefits outweigh the costs. And again, the shadow cost of carbon was developed by economists, so don't ask me any questions exactly how they constructed this graph, but in the year 2025, a ton of carbon will cause approximately 180 euros of damage to the climate and to human health. And this cost grows over time. That same ton will do 400 euros of damage in 2035. So for the last slide, I'll show you how the cost benefit analysis kind of all came together. So in the red column, we have their greenhouse gas emissions for each year. We calculated as much as we could. So about out to 2037, we had data for the greenhouse gas emissions per year. So it's going to grow over time as their production grows, up to what we found in the greenhouse gas protocol, around 46,000 tons. In the green, you have the effect of the mitigation measures. So you have the reduction of electricity, sort of CO2 intensity, using recycled magnets and changing out raw materials. And you have the effect of solar panels. In the orange, you have what their actual sort of emissions would be if you assume that the mitigation measures are actually followed through. And they're about half as much if you compare for each year, or for most years, they're about almost half as much as what it would be without the mitigation measures. So this, to me, makes the project climate proofed and is the final test. Even you may look at the cost on the right-hand side, which is the actual cost to society. Again, if you factor these into the company's internal revenue calculations, it would still be profitable. And this is before you even calculate the benefits of their products in wind turbines and electric cars. So I think might be time to give the microphone back to Heikki. We've got about 15 minutes left. I've reached the end of my presentation, and hope it made sense. Hope you learned something.
Thank you very much, Mart, and also Kristel, for excellent presentations.